Cone problems are always my favorite. A conical reservoir has a height of 20 feet and a radius of 7 feet. Water is poured into the reservoir at a rate of 2 cubic feet per minute. At what rate is the height of the water increasing when the height is 12 feet? Well, of course, first thing we've got to do is draw a picture. So, draw my little cone here. And I'm going to do a little bit of labeling. I know the overall height is 20. I know the radius is 7. And the reason I'm putting that in is those are unchanging. The water height, as water is poured in, that's changing. More water means the height of the actual water in the tank is going up, the radius of the water in the tank is going up, but the actual dimensions of the cone are not changing. Next, we need the rates. Well, the one and only rate we know is the volume. So dV dt is equal to 2 cubic feet per minute. And I want to know how the height is changing. So we need the volume of a cone. Well, volume of a cone is 1/3 pi r squared h. Now we have one issue here, and it's kind of a big one, and that is right now we have two variables, r and h, and if we did the derivative we would need to then do product rule. So we'd have something like dV dt equals 1/3 pi multiplied by, in parentheses, r squared dh dt plus h multiplied by 2r dr dt. We don't know anything about the radius, and in fact, up here you can see we don't really care about the radius. We only care about the height. So to avoid product rule, we're going to set up a little ratio. And this is where the actual dimensions of the cone become so important. We said that we have a radius of 7 and a height of 20. Okay, that's our radius to height ratio. If I did some cross multiplying, I would get that r is equal to 7/20 h. So I'm going to go back here and replace r with 7/20 h. So 1/3 pi multiplied by 7/20 h squared h. Let me keep cleaning. 1/3 pi. Well, 7 squared is 49. 20 squared is 400. And I have h squared, but another h there as well, so 4h cubed. Yeah. Well, let me keep going. 1/3 pi multiplied by 49 over 400 be the same as 49 over 1200 pi h cubed. There's my volume. Now it's not a pretty equation, but it works. Now let me keep working on the next slide where I get a little bit more room. So there was my volume equation. So if I do the derivative of that, just put a d here, I have dV dt equals 49 over 1200 pi, because that's just a constant, multiplied by 3h squared dh dt. Now I can start plugging things in. I was told in the problem that h was 12 and that dV dt was 2. So let's start plugging some things in here on that s step. So we have 2 equals 49 over 1200 pi multiplied by 3 multiplied by 12 squared dh dt. And now it's just about solving for dH dt. You could multiply both sides by 1200 over 49, so we'd have something like 2400 over 49. Divide by pi, divide by 3, divide by 12 squared, so 144, and that's equal to dH dt. That denominator then is 21,168 pi, and that would be your dH dt.